So we've covered complex numbers now, and a complex number has a real part. I think I did that in blue. Real part plus, and there's the other one I did in yellow, imaginary part times I. Okay, so that's like a complex number, and the complex number has to be in this form. So what if for those of you who are going to be electrical engineers out there, sometimes you're going to have to divide. We talked about multiplying imaginary numbers, so what about dividing imaginary numbers or complex numbers? So for example, 7 plus 3i divided by 2 minus 2i. Well, this is not a complex number right now because it doesn't have a real part plus an imaginary part times I. So what are we going to do? We're going to introduce something called the, it's called the complex conjugate. So we have the complex conjugate of a complex number a plus bi. The conjugate is a minus bi. And let's just see what happens when we multiply a plus bi times a minus bi. Well, let's FOIL. For those of you, you can fast forward if you want. If we FOIL this though, we get a squared. Right, that's the first. Then the outer is minus abi. The inner is plus bia. And then the last is minus b squared times I squared. Okay, so let's look at these terms carefully. This one right here, negative abi and positive BIA. These are the same terms. They're just rearranged. The multiplicands are rearranged, but these are the same. So these cancel. And we're left with a squared minus b squared times I squared. Well, we said I squared is just negative 1, so that simplifies to a squared plus b squared. Well, this has no imaginary part. And that's going to be helpful. Because when we have a complex number like this, 7 plus 3i divided by 2 minus 2i, if we multiply by the number 1, so this might be evaluate. If we multiply by the number 1, we won't change anything. This is the number 1 I am going to choose very carefully. What if we multiply by the complex conjugate of the denominator over the complex conjugate of the denominator? Really, all I did was multiply by 1. It's completely legal. No one's going to take me away to math prison. So let's do this. This is, don't whine, because this is just because this looks tedious. Let's do the numerator first. We have 7 times 2 is 14. That's first. Then the outer is plus 14i. The inner is plus 6i. And the last is plus 6i squared. What about the denominator? We have first, which is 2 times 2 is 4. Inner is minus 4i. Oh, that's outer. That's outer is plus 4i, inner is minus 4i, and last is minus 4i squared. All right, let's do the numerator first. Let's simplify the numerator. We have 14 Well, let's look at the I. Let's look at the I, the imaginary part. We have 14i plus 6i is plus 20i. So that's just taking care. That right there is taking care of that one and that one. We have 14 plus 6i squared, but this plus 6i squared is really minus 6. So I'm just going to do a light cross out there and put minus 6. 14 minus 6 is, that's right, 8. So that takes care of the numerator. Sorry, they're so far apart. Divided by 4. We have plus 4i minus 4i, so those guys cancel. And we have 4 minus 4i squared. Well, I squared is negative 1, so that's 4 plus 4, which is 8. Let me write that there. That's plus 4. So that gives us 8 in the denominator. Well, again, we're treating I like a variable. So this is equal to 8 plus 20i over 8. That's 8 over 8 plus 20i over 8. Oh, look at that. Real part, imaginary part, boom, equals 1 plus 20 over 8 reduces to 5 over 2i. So look at that. Look how much simpler that is, or evaluated is, right? So we have this right here came from this. It was a lot of work, but it was worth it. This is a lot easier, and it's now a complex number with a real part. Real part equals 1. Imaginary part equals 5/2.